I'm Charles Wang, teacher from the Central High School. Welcome to today's Chemistry 12 class. Today we are going to talk about the new topics in Chemistry 12, acid, base, and salt. This is the big topics in Chemistry 12, and today we focus on the introduction for today's class. Hopefully you have some idea about what is the acid, base, and the salt in here. And welcome to today's class. Today we are going to start the textbook chapter 4, the unit 4, from the chapter, the PDF file, but actually belong to us is unit 3. We talk about the acid and the base. This one is a big topics. So acid and the base. This one should be a big topics. So make sure you understand if you have the course schedules for this week that will give to you on February 22nd. February 22nd, that will be according to the schedule we are talking about the unit 3, but actually from the textbook or PDF file will be the chapter 4 or unit 4 on the PDF file. So we talk about the acid and the base. Today we try to talk about the acid and the base. If you can, you have the PDF file with you first. Please to have those things with you first. Or if you can find someone, you can get like the textbook or those things. It will be much better. We use the Hampton textbooks. We talk about the acid and the base. Acid and the base. So today we are going to have a very kind of the short, lessons. First of the, from now on, we are doing the acid and the base. And then for the final exams, you must be careful. What's the meaning for this? For this time, I let you go, but not for the final exams. What's the meaning for this? Remember, when we're on the midterm, we give you the data book. It means that everything I will follow the data book. For examples, just for simple examples, aluminum, for example, aluminum 27.0 grams, that's on this data book. Maybe you can find from the other data book 27.01 or 26 point something. I don't know. Or for the PPT form, solubility. Yes, you can find something. Maybe not covered on the textbook data book. I'm talking about the solubility. We only use this one. If you use the others, yes, I understand. Maybe you know much better. I let you go this time. For the final exams, you didn't use the data from here. I put you 0 there. So please make sure you understand. We provide the data book for you already. All the information or all the data number you want to use, you must use the number or data from the data book we provide. So make sure you understand. And another one is the last thing. If you want to use the graphing calculator for the calculation, I agree, you can do that. But you must listen carefully. For example, for any quadratic equation or very hard equation, you want to solve it in the graphing calculator, then you must follow the requirement for the graphing calculator. I can tell you what will be the requirement for the graphing calculator. If you want to use the graphing calculator to get the answer. First one, you must give me the screen size. You must give me the X domain and the range for the Y. And then you must give me the function f of x. And then you must tell me where is the x-intercept, y-intercept, and show me the pictures and tell me the answers. That's the requirement for the graphing calculator to use. Where is these requirements come from? Come from the long time ago. We have the math provincial exams. If you want to use the graphing calculator, you must show all the information. Okay. We have a question for this time for the midterm. That's a kind of the hard question, not hard, okay? A little bit complicated to solve on the quadratical equation. Don't just write down the equation, okay, even you didn't simplify and tell me, okay, you got the answer or whatever, whatever, okay. The test question for the midterm, most from the, okay, the questions you should know that before. You have enough time to finish. You have enough time to finish. Okay, because I did all the questions, I checked all the questions. You have enough time to finish. Okay, so please make sure you understand. Make sure you understand. You need to do the question step by steps. You want to jump the steps, then the only thing I can do is deduct your marks. Okay, so make sure you know that, especially for the rest of the test and especially for the final exams. Now we talk about.
Can I ask?
Yes.
So I have 2 quizzes that has already hand in on time, but you didn't give me the marks.
You are. What's your name?
佳琪瑜.
Okay, I will double check for that one because I believe we have a couple of people didn't get the marks back because and I have troubles to look the questions. Okay, I will try to email to you about what do I think. Okay.
Yeah, because I've like waiting for these 2 marks for like almost a month because you said you will give us a Gmail to explain what's going on. So I was wondering.
Yeah, because I talked to the school about this, and then I will email to you. Yes, I believe that's yes. I think 1 or 2 quiz. I think we have a couple of people didn't get a quiz back. Yes. Okay. And yeah, I will hold on. I think now I scanned the papers already. I will try to find from my USB. I think I scanned from the school. Yes, I think I scanned from the school. I will try to email to you tomorrow. Okay. Yes. Okay, now we'll talk about the chapter 4 in here for the acid and the base. For the acid and the base. Okay, acid and the base. First one, okay, we talk about what is the acid and what is the base. This is a big topic, and then we must know what is the definition for the acid and the base. First one, the first definition comes from a long time ago. People understand anything dissolved in the water, can produce H+, can produce H+. Then we call the acid. We call the acid. Anything dissolved in the water can produce OH-. We call the base. That's it. That's it. Long time ago, there's one person called Arrhenius. So we call the Arrhenius theory for the person like this one in here. What's the acid? Okay, release H plus in the water. What's the base? Release OH minus in the water. What's the salt? Your acid plus the base become the salt plus the water. Like this one in here. Like this one in here. That's the basic definition for the acid and the base. For the acid and the base. Okay. For the acid and the base, that's the basic definition from the person, and then that is a kind of the classical definition for the acid and the base. That's the first thing. And then acid plus the base become the salt plus the water. Then the question is, what is the salt? Salt, usually the salt is kind of the, ionic compounds. Ionic compound, metal with the non-metal, metal with the non-metal, like those things in here first. So we use the very simple, formulas like the H acid plus the, BOH. They will become the OH and H become the water. Plus the, A and the B will come together. So this one we call the salt. Usually your H carry the H plus, your A carry the A minus, your B carry the positive and the negative. And then metal with the non-metal, then or positive negative. Usually this one, the salt is kind of the, ionic compounds. Yes, but sometimes it's not, but that's okay. But in here, we just want to make sure you understand your acid plus the base will give you the answer for the salt plus the water. So make sure you know that. Make sure you know that. That's the first thing we try to talk in here. Then we try to talk the second thing in here. We try to talk about the acid. We try to introduction the acid and the base, and then we try to introduce the acid. Acid we have lots of the real life with the acid, like the vinegars, like the other kind of things in the real life. On the base, usually for the cleaning stuff is kind of the base. And then for the food, we have the like the Coke, soft drink usually is the acid. And we have some drink like a base. All the different kind of things in the real life. The question is, will we test you which things belong to the acid, which things belong to the base? Not exactly. But we will test you only one thing. Maybe we will test you about your stomach acid. You have acid in your stomachs. It's kind of the dilute strong acid. It's kind of a strong acid. Why? Because you need those kind of strong acid to protect your body. Everything go to your, whenever you try to eat, go to your body, the first time when they go to your stomachs with a strong acid, they try to kill all those virus, disease, those kind of things. Make sure anything or everything go to your body will be safe. So your stomach acid is kind of the strong acid. That kind of the strong acid we call the very, very special one. We call the hydrochloric acid, HCl. HCl. HCl is kind of the very strong acid. Then you will ask, Mr. Wang, what's the meaning for the strong acid? Definition for the strong acid is very simple. If this acid can go to the water, 100% ionized. It means if this one carry one H, they are going to release the whole H in the water. We call the strong acid. For anything release the OH minus, 100% release OH minus, we call the strong base. It's kind of like the chapter 3, we talk about the solubility. Remember, if this one can dissolve in the water completely, we call the soluble. If they only can be dissolved partially, less than 0.1 m, then we call they will form the PPT. Similar things in here. For any acid, if they can, they go to the water. If they can release H+, 100% release their OH+, we call the strong acid. If they has less than 100%, 90%, 60%, or 99%, or 1%, we all call the weak acid. Then you will ask, the range is too big. From the 0.1 to 99.9, we all call the weak acid. But in the real life, whenever this one belongs to the weak acid, usually they release H+ less than 20% or 30% in the water. Usually like this. Yes, you still have some higher, but usually less than 20%. Most of the case is less than 5%. So it's still acceptable on chemistry 12. It's still acceptable. Then the question is, how do I know which one belong to the strong acid, which one belong to the weak acid? Like we learned from the chapter 3, how do I know which things are soluble, which things are PPT? Remember, we have lots of people did many experiments before, so they have a table. Same thing in here, we have the table for the strong acid, we have the table for the weak acid. That's the same thing in here. So that's the second thing. We try to explain what is the strong acid, what is the weak acid, what is the strong base, what is the weak base, has nothing to do about who you are, what you are doing. It all depends on whether we put you into the water. How much percent you can release either H+ or OH minus. If you can release 100%, we call you strong. If you only release less than 100%, we call you weak. Doesn't matter you release 90% or 5%, we all call you weak. That's the second thing. We explain to you what is the strong, what is the weak. Then we explain to you the third thing is, even we define the H+, we call the acid means for release H+ in the water. Later on, we found this kind of the definition. Sometimes it's not very good when we try to solve the question. Then we say, we assume you release the H+, you release the OH minus. You release the OH minus, maybe looks like you receive H+. So we say that anything can release H+, or we call we can release or give away proton, give away proton, or H+, we call the acid. Anything can receive H+, because you give something out, there must be something to receive. anything receive H plus, we call the base. We call the base. That's the new definition. We call the Browns-Lowry acid base. That is a very, very general definition for the acid and the base. They use this one to, define the acid and the base. Anything can donate a proton. We call the acid. Anything can receive a proton. We call the base. So this one is a new definition for the acid and the base. This one is the all-time, definition for the acid and the base. If you look the tables, most of the time they still use the basic one in here. They still use this one. Even now, you go to the outside, you ask the people if they learned the chemistry before. What's the acid? The first response will be anything release H plus, or anything carry the H this out. What's the base? They will give you the answer in here too. It's hard to find some people answer to you, donate a proton or receive a proton. Now, we try to talk about the proton in here. Because original one, we talk about H plus, but now the new one, we talk about the proton. First one, we ask ourselves, what's the difference between the proton and H plus? Any difference between those two terms? First one, we understand hydrogen is the only atom without carrying neutron in the nucleus. Hydrogen, very basic structure. One proton and one electron in here. Electron is in here. That's the hydrogen in here. So whenever the hydrogen lost one electron, become the H plus. What's the meaning for this? This electron disappear. They only carry the proton in here. They only carry the proton in here. Remember, the positive density is very high because that's a single charge and a positive charge only. So we understand inside of the water have the H2O is the polar bonding. So O is on here with the H in here and H in here. And oxygen have the A electrons, but the valence charge or valence electrons is a 6 with 1 in here. 1 in here, we still have a 4 on here. So oxygen have the 4 electron in here with an angle 108 degrees. So inside of the water, if this water is in the acidic solution, you have H plus on here, P plus or H plus on here. The H plus, look the electron on here, H plus will automatically stick on here. Remember, positive, negative, they try to attract to each other. Then they form something we call the H3O plus. We call the hydronium in here. We call the hydronium on here. That will give to you the name on here. Hydronium ions or hydrated, okay, protons. This is a special name. This one tell you one important information. If the water on the acidic solution or an acid in the water solution, it's impossible to have the H plus itself stay inside of the water. That's impossible because this one is the high positive density. It will find the electron from the water by itself and combine with the water to form H3O plus. H3O plus, one H plus come from the, okay, the positive hydrogen or proton, and another H2O from the original water. They will form together to form H3O plus hydronium ions. That is what happened inside of the acidic solution. That's the first thing. Now, people found this one a couple hundred years ago. They found it already. And then they understand there is no H plus in the water. You only can get H3O plus in the water for the acidic solution. But the question is, people use H plus for many, many years. You want those people to change their habit? That's impossible. That's the reason why so far we still use H plus. But for the scientific science persons, usually they use the H3O plus. But for us, most of the case, we still use the H plus. Even for the table, on the table, if you look at the table on the data page, data book page 6, everything in here, we still use the H plus. Actually, for the writing method, the correct way is you need to do some adjustment, put the H3O plus on this. But people didn't do that. We still use the H plus in here. Make sure you understand. Make sure you understand. The actually correct thing is H3O plus. So make sure you know that. So we try to do the couple things in here. We introduce the Arrhenius theory for the acid base. Anything can release H plus in the water, we call the acid. Anything can release OH minus in the water, we call the base. Then we introduce the bronze-lauric acid and the base. For anything can donate H plus, we call the acid. For anything, okay, can receive H plus, we call the base. And then we introduce what is the strong acid, what is the weak acid. Depends on how much percent you release H plus in the water. If that's 100%, we call the strong acid. If that's less than 100%, we call the weak acid. And the last one, we introduce what's happening. The H plus stay inside of the water. We found H plus cannot stay by itself. They must combine with the water molecules and then form the H3O plus particle in here. That's everything we need to understand first to make sure you don't have any troubles. Then we can keep going for this. We are going to take a break, and after break, we keep continue for this. Okay. We try to ask ourselves what is the meaningful free products. It means that for some ions or for some particles, they are in the solution. They are in the solution, but they don't do the chemical reaction to the others. Remember my words, they will be in the solution, but they didn't do the chemical reaction to the others. They didn't do the chemical reaction to the others. What's the meaning for this? It means that they only stay in the solution, but they don't do the chemical reaction to the others. The very, very typical examples is like the alkaline metal ions, like the sodium, Na. Sorry, sodium, yeah. And the lithium, Li, and the potassium, K. Those kind of the alkaline metal ions. When those things dissolve in the water, 100% soluble, and usually they don't do the chemical reaction to the others. They try to, release one electron, and then become the ions stay in theirs. Why? Because now they become very stable. Because they lose the one outside electron, they become the, very stable atoms. So those are the things we call the amphiprotics. They dissolve in the water, but they don't do the chemical reaction to the others. Now, that's the first part in here. Second part, we try to do the question like this one in here. For example, we understand the ammonium ions react to the water, become the H3 plus the H3O plus. This one dissolve in the water, produce H3O plus. It means they will produce acid. So this one tell you, this one dissolve in the water will produce acidic solution because they can release H3O plus in here. But this one is not our purpose to put the example in here. We have 4 particles in here. We want to find which one belong to the acid, which one belong to the base, or they belong to the salt. First, we always go from the left to the right, or you can say the forward reaction, left to the right. First one, we ask ourselves, how can my NH4 plus become the NH3? Remember, you try to change from the NH4 plus, become the NH3. You try to go from the left to the right on the same time, you lose one H. What I said, you lose one H. Then we call the acid. Remember, if you lose one proton, you are the proton donor. What's the meaning for the donor? You give away one H plus. So this one belongs to the acid. From here to here, you give one H. So you are the acid. Now we ask ourselves, if you go from the H2O, become the H3O plus, you receive one H plus. you receive 1 H plus. Then you can go from the H2O become the H3O plus. So we call the base. From the right to the left, you go from the H3 become the H4 plus. You receive 1 H. So from the right to the left, you are the base. From the right to the left, H3O plus give away 1 H plus. So this one is the acid. Those two is a pair. We call the conjugate pair. This one is the conjugate base. This one called the conjugate acid. Those two called the conjugate pair. This one called the conjugate base. Conjugate acid. Just the kind of the names. Think about that. What Mr. Wang said in the beginning of the class. Acid base will cover so much things. First one, we introduce Arrhenius theory for the acid and the base. What is the acid? Anything can release H plus in the water. We call the acid. What is the base? Anything can release OH minus in the water. We call the base. And then we introduce what is the strong acid? What is the weak acid? Doesn't matter which kind of the acid. Depends on how much percent you can dissolve in the water. If you can dissolve in the water 100%, we call you strong. Doesn't matter you can release H plus 100% or OH minus. We can call you either strong acid or strong base. What is the meaning for the weak? Anything dissolved in the water less than 100%, then we call you weak acid or weak base. And then we try to introduce what's happening. H plus inside of the water we found is impossible. It's impossible to have the H plus inside of the water. They will combine with the water to form H3O plus. We give a special name, we call the hydronium ions or hydrated ions. And after that, we learn something we call the amphiprotics. Anything, okay, if they don't do the chemical reaction in the solution, we call the spectators. Like I call my student before, a long time ago, call my students spectators. They come to the class and do nothing. It's kind of the spectators. They don't join the class time. They don't participate the class discussions. They even don't do any questions in the class time. So we call the spectators. Then we found people think we need to generalize definition of the acid and the base. So we introduce the Browns-Lowry acid-base definition. From that definition, what is the acid? Acid means anything can donate H+. We call the acid. Anything can receive H+. We call the base. That's the new definition for the acid and the base. After that, if we understand this kind of definition, we use the chemical reaction from the left to the right. We can find who is acid, who is the base. From the right to the left, we can find the same thing, who is acid, who is the base. The two are very similar, NH4 plus and NH3. We call the conjugate pairs. Conjugated pairs. H2O and H3O plus, we call the conjugated pairs. If inside of the conjugated pairs, this one is the base, we call the conjugate base. If this one is acid, we call the conjugate acid. That's everything I want to talk today, give you the introduction in here. The last one, remember we mentioned about in the real life, we have so much different kind of things for the acid and the base. The most important is in your stomachs. We have the hydrochloric acid, that's a strong acid. The strong acid try to protect you, Remember for the biology, we call the enzyme. Enzyme, it means inside of your body, you have something try to help you to keep your body's balance. And then for the stomachs, we have some enzyme too. Those kind of enzyme help you to digest the food. And those enzymes only can function on the acidic solution. So then you will ask, this one I didn't learn the biology before. I have no idea about the enzyme. That's okay. Enzyme is a name in biology. In chemistry, we call the catalyst. Then you understand we call the catalyst. It means they try to help you to improve the chemical reaction rate, make the chemical reaction become faster. Okay, just the different name. Same thing, different name on different subject. So that's in the real life you must understand. And usually for the cleaning stuff, like a soap, like those kind of cleaning stuff, usually belong to the base. And then for the soft drink, and even for the milk, I always thought it's when I was young, I thought it's the base. And then it's a kind of the little bit acid, almost like a neutral. And but for the softer drink, is kind of the weak acid. So just need to know that. So that's everything for today's class. Hopefully you understand, and then you have time to study the PDF file first before you come to the next class. Now I try to check the attendance first for the chemistry class. Today is the February 22nd. That many people? No, I don't think I've got many people. Okay, that's everything for here. Okay, that's the everything for today's class. If you have any question, you can stay here to ask. Otherwise, you can leave.